Day 66. Today we're going to be talking about calculating quadratic components. So we've already kind of talked about how we graph these and different pieces of them, but now we want to talk about how exactly do we find all of those values. So most of this you already know, so it's going to be a review, but there is some additional information. So let's go ahead and get started. So, first thing, anytime I want to deal with a quadratic equation, I always want to make sure that it's written in standard form. Always ax squared plus bx plus c equals 0. Sometimes we can change it to a y, an f, whatever. Now, my axis of symmetry. What was that again? My axis of symmetry is where my graph is cut exactly in half. It's the mirror line. And it has its own special formula. X equals negative b over 2a. Always it has an equation of x equals some number. So let's plug those in. My axis of symmetry is located at x equals 2. All right. So how do we find my vertex? My vertex. Okay. So my vertex is going to be the point on the graph that's directly in the center, and it's either at the very bottom for a minimum, an upward opening graph, or it's at the very top, the maximum, for a downward opening graph. Now, the great thing about this is we already have half of it. The x is located at 2, and we just don't know the y. So, what can we do? Well, we can go ahead and plug this in. So I'm going to go ahead and plug that in. I'm going to say y equals negative 3 into 2 squared plus 12 into 2 minus 10. Noticing I'm just plugging in x equals 2 in order to find a y. So now I'm going to go ahead and start reducing this. So I find out that my y value when x is equal to 2 is also 2. So this is a vertex. But just by looking at my equation, how in the world do I know if this is a minimum or a maximum? Well, I look at that a value. If it's positive, it's one of these guys. It's facing the normal way. If it's negative, it's one of these guys over here. So because this one is negative, this is going to be a maximum. Now, what about my y-intercept? Well, 99% of the time that's going to be my c value, but my y-intercept also means x equals 0. So I want to plug that in order to find my y. So I copy down my equation, negative 3 times 0 squared plus 12 times 0 minus 10. Cancel, cancel. My y-intercept is negative 10. My x-intercepts would be whenever we do all of our factoring, remembering that that only works for certain things, okay? It would usually give us x minus something, x plus something multiplied together. We'd split them apart and get an answer. This is how we do it by hand. My domain for all of these graphs is all real numbers. That funny looking R. However, my range is the one that I have to be careful of. So I said earlier that my vertex was located at 2, 2. So I have to put this number somewhere in my range. Now, I look at it and I say, okay, this was a maximum. That's the highest that it can go. So I'm going to write it in my second slot. Over here, I put negative infinity and my extra line. Now I have my range. Okay. So now what I want to do is I want to just verify this with my calculator. So I'm going to go ahead. I'm going to head home. I'm going to go ahead and open up a new graph. And I'm going to go ahead and type in my equation. Negative 3x to the power of 2 plus 12x minus 10. Okay, so I have my graph. I'm going to do a graph trace. So I'm going to hit menu, trace. Let's see what trace all does. Oh, that's ugly. Let's not do that. Let's do trace, graph trace. All right. So look at that. It immediately started on a y-intercept. 0, comma, negative 10. Oh, that's exactly what we got. Okay, so we're good. So I'm going to keep scrolling over. There's a 0, my x-intercept. It looks like it's located somewhere around 1.18, and this is approximately 0. So that means this is not an exact answer. Keep going, going, going. Maximum, my vertex. This is also where my axis of symmetry is. X equals 2. X equals 2. That's my axis of symmetry. Keep going. There's my other 0, 2.82. I have everything. Now I can go ahead and look at that domain. I don't see any holes, and it looks like that graph is going to keep going way out there, way out there. So I would assume all real numbers. But that range, notice how whenever I zoom out, let me see if I can get it to zoom out here. Menu and, whoops, come on computer. All right, menu, zoom out. All right, I'm just going to keep zooming out, way out. Okay, so look at that. So it does look like it's going to keep going eventually, but this is the highest y value that I'm going to have. There at 2. So it's going to go way down here from negative infinity, all those negative y values, all the way up to 2, and then nothing. That's why 2 is our cutoff point. It is for our range. Okay. So just to put this out in words, so by looking at the sign of A, we can determine if the graph is a upward, positive, or downward opening graph. When it is positive, the graph opens up and it has a minimum. When it is negative, it opens down and has a maximum. In order to find the y-intercept, as is the case with every single equation you will come across, as x has got to be equal to 0. So I plug in 0 wherever I see x in my equation and simplify to find the value. To find my x-intercepts manually, there's a lot of different things that we can do, but we did learn one of them, which is factoring. All right, so let's go ahead and take a look at this one as well. So here I have a graph of y equals x squared plus 2x minus 3. We can determine the axis of symmetry from an equation using the formula x equals negative b over 2a. But I don't even need to do all of that. All I do is find the exact middle of the graph, draw a line straight up and down. Wherever it touches, there's my equation. I'll continue identifying information. So I see that as my axis of symmetry. That means that this guy's got to be my vertex. Since it's at the bottom, this is a minimum. Over here is an x-intercept. Over here is my y-intercept. Over here's another x-intercept. And I believe that is it. Pretty simple. All we have to do is just identify, where is it touching the x-axis? Where is it touching the y-axis? What's the middle of it? And what's a line that goes directly through the middle to cut it in half? Okay, so let me finish filling this in. Once we know the value of the axis of symmetry, we can use this information to find the vertex by plugging in the value of the x-coordinate back into the equation to determine the value of y. I spelled that horribly. Okay. Coordinate. There we go. All right. So that's it for today. Again, you should be able to follow this process. It's fairly simple. First, you can use this, and then you should be able to get this number and this number. They're the same. Then I plug this number into my equation to get this one. Now I have those. I can tell if it's a maximum or a minimum by looking at the sign. Positive, minimum. Negative, maximum. My y-intercept means just plug in a 0 for everything where x is. And most of the time, that c value is going to be my y-intercept, the number that's by itself. Okay? All right. See you guys next time.